over b minus a. Yes?
Can the bottom be interchangeable?
No, you can't interchange these. It's always, a is always the point to the left, and b is the point to the right. The problem is if you switch them, what it's going to do is it's going to change the sign of your slope. So instead of sloping this way, it's going to slope the other way, and it won't be right. Everyone got that? Okay, let's see what this is. What is this? Negative 15 on top, right? Over 3 on the bottom. And you get negative 5. Negative 5, right? That's just the average rate of change, right? But that average rate of change is also what? The slope of the secant line, right? Which is what part B is about here. Where the hell is it? There we go. So we've answered part A, right? This is part A. Negative 5 is the average rate of change from negative 2 to 1. Now, find the equation of the secant line containing those 2 points. These are the 2 points they just gave you, right? You plugged in negative 2, we got an answer. Plugged in 1, got an answer. So even though that looks confusing, that's just saying those 2 points. Find the secant line between these two. So, Dea, am I saying that right? Dea? Okay, so do you know what we're going to do for this?
We find the slope.
Which we just did that, right? For part A, we basically found the slope. What do you need to find the equation of any line? What was the formula we just put?
The
Point slope formula. So tell me what that point slope give me the formula.
y minus y1 equals m times x minus x1.
Okay, now you need a point and a slope. Do you have a point?
Yes.
What is it?
What? Can we use any point?
You can use either one.
Okay. So we can use negative 2.
You want to use this one? x1, y1. Okay, so you have your point. Do you have your slope?
Yes.
What is it?
Negative 5.
Okay, that's it. Plug and chug. All right? So go ahead. It'll be y minus what?
19.
19 equals
Negative 5.
negative 5. That's our slope. Parenthesis x minus negative 2. It's a double negative, so it'll become positive, right? So y minus 19 equals negative 5 times x plus 2. And that's your equation. You can clean that up now, right? So y minus 19 equals negative 5x minus 10. Y equals, we'll add 19 to both sides, plus 9. Well, I'm about to find out because I'm going to graph it, right? When I graph this, what should I see? When I graph that, what should I see on this picture? The line connecting those 2 points, right? 5x, negative 5x, plus 9. You don't need to graph. I mean, during tests, you won't have a computer out or anything. So you can use your graphing calculator, but right? That's just to verify and like visually see what we've done, right? We've just found the equation of the secant line. All right, I believe that concludes this section. Yes, the rest is just homework now. Okay? The rest is homework. So try and do everything there. You know what? I would like to do these problems with you. I think this will be a good review problem before we move on. Unfortunately, oh yeah, it's just enough room here. No, it's not. I have to zoom out just a little bit. Is that really hard to see? You know, it's kind of hard to see this. See what these questions are. All right. Here's what I'll do. I'll just write the questions out. I'm not going to go through every one of these questions. Okay, you ready? Is that better? Can you see that better? All right. Move it up a little bit. Yeah, there we go. Okay, look at that graph right there. You ready for some questions? First question, part A. And I'm calling on people. Part A. Part A is going to, is it Meenan? Am I saying that right? Meenan? Yes, am I saying that right? Yeah, that, you sure? Manan. Okay, well, I'm not saying it right. Okay, let me put something here so I say it right. And I'll probably say it wrong anyway, but I will try. Okay, Minan. My question to you is, and I hate to put you all on the spot here, but you know, you have a test in a week, so this will be good for you. What's the domain of this function? So you remember how to do domain? No?
I do.
Okay.
Yeah.
Start to where it ends.
Yeah. So it'll be -10. Yeah, -10 till 7.
Good. Okay, do I include -10?
Yes.
Okay.
Because it's a closer.
So the domain of this function, you're saying, is -10 to 7. Everyone understand and agree? Okay, that's domain, because with domains, you're looking at like a vertical and you're moving left to right, you're seeing where your function's defined. All right, very good. Let's see who's next. Oriola? Oriola? How do I say that? I said, that was pretty good then, right? Oriola? Okay. All right. So you get range. All right? Range. So with range, do you know what you're supposed to look for? Like instead of left and right? Up and down, right? Go ahead. -4 is the lowest point, and then it goes up, and you've got graph until where? 10. Yes? And brackets on both, right? Okay. -4 to 10. Good. C. All right. What do I want to ask next? Joshua. Where's Joshua? Okay, Joshua. Is this an even function? I understand I'm putting you on the spot. Do you remember what even meant? No. Okay, so even means if you look at the graph of this function, is it a reflection of itself over the y-axis?
Oh, okay, all right.
So is it a reflection of itself over the y-axis?
No.
No, it's not. Right? It's not a reflection over the y-axis. Mario. Wait, no, Moro, sorry. Moro? Mato? Say it again. Mato. Oh. Okay, Mato. Is it odd? Do you remember what it means to be odd? No? Okay, so odd would mean that if you reflect it over the x and then over the y, like a double reflection, it would be the exact same function. No, it's not. Okay, so it's not, right? Is it odd? No. All right. Rafe? What? Wait, where? I was going to say that, but then I was like, okay. I've got some challenging names in here. Rafe. I don't even remember what I was going to ask you. All right, how about this? Where is f increasing? So do you understand what I'm asking for?
I think so.
Think so? Okay.
So from -8, x increases to -2.
Okay, everyone make sure we follow this. We're asking, where's this graph going up, increasing? So you're looking, Rafe is looking at the x value where we start going up. This is where we're going up, right? Go up here from -8 to where?
-2.
To -2. Let's start with that. And when we do this, I told you just always use parentheses, right? So go -8. Oops, I almost did infinity. Like math, like in the math world, the real math dorks, we call that lazy 8. That's infinity. We call it lazy 8. It's late 8 laying down. It's so dumb. Okay, I didn't make it up, all right? All right, -8 to, you said what, -2? Okay. Is that the only place it's going up?
No.
Where else?
Then from 0, 0,
0, so the 0 here to
x equals 2.
2, 0 to 2. So I would put a union symbol here, and 0 to 2. I need you to use the union symbol. I know at least on one of your quizzes I took off just a little bit because I think someone put a comma here instead. It needs to be the union symbol. Is that the last place it's going up?
And then from 5 to 7.
From 5 to 7. Good, from 5 to 7. Very good. All right, so let's see who's next. Indiana. I'm saying that right? Okay, good. Where is it going down? Where is F decreasing? -10 to -8. I'll put parentheses on those, right? Anywhere else? -2 to 0. Anywhere else? 2 to 5. Do you all agree? From -10 to -8, we're going down. From -2 to here, we're going down. 2 to 5, we're going down. Perfect. All right, y'all are going to do great. This test is going to be awesome. Leslie.
Yes.
Okay, Leslie. All right. Leslie, what are the x-intercepts of this function? -10, 0. Is that an interval or a point? Point, right? So we have some issues in our mathematical notation that it's hard to tell the difference between intervals and points. So you have to understand the context. You understand that that's a point, okay? So I will do a comma now because I'm doing another point.
-5, 0.
-5, 0.
And 0, 0.
0, 0.
And 5, 0.
Okay. Is that all of them, everybody? This is good? Okay, very good. You want to give y-intercept while you at it?
Sure.
Do we have any y-intercepts? 1?
0, 0.
0, 0. Okay, it only hits the y-axis in one place. G, H. Okay, good job. Y'all are doing good. Okay, Caleb. Okay, Caleb. Oops. Caleb, can you tell me what this is? Can you tell me what f of -2 is? So when you plug -2 into the function, what does it spit out? Do you know what it's asking? No? This is the x that's being plugged in. This is your x value, and I'm asking what y value do you get? 6, right? 6, that's it. Yes? Got it? I'm going to ask you another question, Caleb. How about this? For what x is f of x equal to 10? Let's call this I. So sticking with Caleb here. You see the difference between these two questions. This one I said, hey, what happens when you plug -2 in? You said you get 6. Now I'm saying, what x value do you plug in to get 10? Can you tell? 2. Everyone see that?
Yep.
2. Good. So x is 2. Okay. We're doing on time. Rushton. Rushton? That's you? Okay. All right, Rushton. Let's see what I want for Rushton. Local max. J, local max. What'd you say? Okay, 10 at x equals 2, so you have a max, a local max of 10 at x equals 2. Any others? Hold on. You're not up. 6 at negative 2. That's all right. Any others? 7 at 3. I think you said it the other way around, but local max of 3 at 7, right? Any others? Local max of 0 at, no, yeah, at x is negative 10. Everyone got that? We just did this today, right? So this is a local max. The local maximum value here is 0. It happens at negative 10. Local max of 6 happens at negative 2. Local max of 10 happens at 2. Local max of 3 happens at 7. Yeah? Do you have a question?
Is this one in the book?
Yeah, this is in the ebook. Yep, this is in the ebook. Pardon?
This is our homework.
Don't think this is the, well, is this the homework?
Because I saw them highlighted, so.
Yeah, you know what? I think this is, yeah, this might be your homework. Yeah, these are all a bunch of your homework problems. But I'm not doing exactly what they're asking. I'm asking some of what they're asking and some of what they're not. Okay, local min is going to be Mario. Mario? 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 Nope. Alejandro we got. So there's 2 Alejandros in here.
I'm Salas.
You're solid? Okay, so you're up now. Local min. Do you understand the local max and min concept? You feel good? Okay, so local min. What do you got?
-4.
Local min of -4 at x is
Negative 8.
-8. Do y'all agree?
Yeah.
Yes? Keep going.
And 0 at 0.
0 at 0.
And 0 at 5.
0 at 5. Anything else? Those 3? That's it? Yeah. Okay. Gianna. Gianna? Am I saying that right? Okay. Gianna, absolute max and absolute min. You get both of them. So how about absolute max? Max of 10, you said 10 at x is 2? Okay, and then absolute min? X is -8 and -4. Y'all good with that or no? Everyone's happy with that? Okay. I like it. I believe that's all that we can really do here off this graph. I think we've covered a lot of stuff there. Do your homework for that section. You should be able to do all of it now, right? Because I had told you to hold off on some of it, right? So now you should go back and just do everything. All right, now we have 15 minutes left. Let's just keep going, all right? Even though we're going to start a new section here, 3.4. So 3.4 is called the library of functions. So I look at this way. Yes?
I know you said that the y, like for local max, if you put a point, sometimes like you said the other one, you're looking for the y and not the x. On the test, do we have to write it like that, or can we just put the point?
You can put the point, that's fine. The reason why I like that is just because like I wouldn't give this to you on a test, but like this right here. Like how are you going to write that? You can't give me the point, right? You have to give me all of the points. So you have to have some way of saying that. So, but on the test, if you don't want to stress out about it, just give me the point. All right, so this next section is called the library of functions. And what this is like, think of like a toolbox, right? I mean, some of you might be handy, some of you may not. But everyone understands the idea of a toolbox, right? You open it up, what's inside of a toolbox? The things that people need to work on stuff, right? Screwdrivers, hammers, right? The basic essential stuff. That's what this is about. This is about what are the functions moving on through pre-calculus into calculus. What are the functions that you need to like have in your toolbox that you know what they look like, you're familiar with the way they look visually, how they behave, that you don't need a graphing calculator, you don't need to go look it up, it's just something that you know, all right? And we're going to go through all of them, and all of them look a little different, they all have different names, and we should just become intimately familiar with all of them, all right? I'm going to go through in a slightly different order than the book does, okay? I'm going to do my own order. But everything I do up here is going to be in the book, all right? So the first function that we want to look at is what we call a constant function. And that's f of x equals c. Now here c is any number we want. Okay. Just don't even have it in here if you're just going to be on it the whole time, okay? All right. So c can be any number, all right? C can be any number. So 4 or 5 or -2. What does the graph of this look like? Anyone know?
Just a line.
Line, what kind of line though? It's pretty special.
Linear.
Well,
Like a straight line.
straight, well, lines are straight. A little bit more.
Uh,
What is it? Rafe, did you say?
Okay, I mean, I was torn between horizontal.
It's horizontal. It's horizontal. See, this is saying this function always spits out the same number, right? No matter what x value you go to, it spits out c. So if I go to 0, it spits out c. If I go to 1, it spits out c. If I go to 3, it spits out c. Right? No matter what number, I get the same output. So I'm going to put here, that's c, and the graph of this would look like a flat line, like through there, horizontal line. Everybody should know here that a constant function is a function equal to a number, and that's always a horizontal line through that number on the y-axis. That's your first one. The next function, these are gonna just slightly get worse and worse. Not worse, but more complicated. The next one is what we call the identity. And that's the function f of x equals x. Any ideas why we call that the identity?
Because it equals what you plug in.
It equals what you plug in, exactly. Whatever you plug in is what it spits out. If you plug in 1, it spits out 1. You plug in 2, it spits out 2. You plug in -5, it spits out -5. Whatever goes in is identical to what comes out. It is the identity. It returns exactly what you plug in. So the graph of this function, everyone here, again, should know what this looks like. It is a line, okay? But it's a very special one. It's the line that is the perfect 45-degree diagonal line like this. And think about why it would be 45 degrees. If you plug in 1, you get 1. You plug in 2, you get 2. So the amount that you go over is the amount that you go up all the time, right? Over, up, over, up. That's your identity. The next function is called the squaring function. And guess what it does? It squares what you plug in, x squared. This one, it's a quadratic, which we'll study more later, but it starts out when you plug in 0, you get 0, right? When you plug in 1, what do you get? 1 in, you get 1 squared. Plug in 2, what do you get? 4. Plug in 3, 9. So it's not a straight line, right? It's got a curve to it. And it screams as you go to the right. And then to the left, -1, you get the exact same thing as you had over here, right? Hey, wait a minute, hold on. That's a good one. I like that marker. In my Cal 3 class, the board is so screechy on every marker I use. It's just the whole time.
Was that a plan?
Yeah, no, I didn't plan that. Okay, so let's stop with these on the board right now and let's just talk about something. You ready? It's going to be fast. Domain. All real numbers, -infinity to infinity. Range. C. That's it, right? Even or odd? Even. Reflection over the y-axis is the same function. Yes? Increasing, decreasing, constant? Constant. Where is it constant? All the time, right? You see what I'm doing? All the functions, all these toolbox functions, we should be familiar with all these ideas. Domain, range, all that stuff. Okay, this one. Domain. All real numbers. Range. All real numbers. Sorry, what's next? It's increasing all the time, right? It's an odd function. Reflect, reflect, right? Double reflection, it's over itself. Okay? Domain. All real numbers. Range. 0, including 0 to infinity, right? Even or odd? Or neither. Remember, there's a neither option also. Even, right? Okay. Let's keep going. Local max, local min, absolute max, absolute min. Same ideas, right? I mean, you should be able to look at each of these now and entertain those ideas, right? This would have a what? Local min and an absolute min. No local max, no absolute max. This one, the cubing function. It cubes what you plug in, right? And so if I plug in 0, 0 cubed is 0. If I plug in 1, 1 cubed is 1. If I plug in 2, what's 2 cubed? 8. Let's get the fun marker. Where is it? I don't know where I put it. Okay, plug in 2, you get 8. So 8's up here. Looks almost like this, right? It's not the same as this though, because this one grows, right? 1, this is 2 is 4, here 2 is what? 8, so it's further up. The big difference though is this. -1, you no longer get positive, right? Because -1 times -1 times -1 is -1, so you're here. And then -2 cubed is -8, so you're here, so it looks like
What is it called?
this. This is a cubing function or cubic function?
Like the actual thing, because that's called a quadratic. So, yeah.
Cubic. This is a cubic.
Oh, just
Yeah, this could be referred to as a cubic polynomial function, or a third degree polynomial function.
Wait, so would that be over the origin?
This is, oh, yes, as far as even or odd, this is odd.
It's the same as identity. Right?
It's odd. It's the same as this. These two are both odd functions. Domain, all real numbers. Range, all real numbers. It's always increasing, right? From left to right, it's always going up. I didn't talk about intercepts. This has an x-intercept, that has an x-intercept, that has an x-intercept. Does this have an x-intercept? Not right now, but if you move C down to the x-axis, then every point is an x-intercept. Okay, got them? Good, good? All right, let's see if we can get the next few up here. The fifth one that everyone needs to be familiar with is the square root function. The square root function is f of x equals the square root of x. And here's where we run into our first function that has a domain problem. Because you can't plug negatives into that, can you? And so could you plug 0 into this? Yeah, square root of 0 is 0. If I plug in 1, square root of 1, 1, right? Square root of 1 is 1. Square root of 2, I don't know. Square root of 3, I don't know. Square root of 4, 2. So if I go out to 4, I go up 2. And this continues, right? The next square root I'm going to know is what? 9, and then 16, and then 25. So it starts to grow like this. Its growth, it's slow. It grows slowly, but it does grow.
Then you can't have negatives.
Can't have negatives at all. So what's the domain of this? 0, including 0, right? Bracket to infinity. Range? 0 to infinity also. This goes up. It's just slow. So domain and range are both the same here. It's always increasing, right? From 0 to infinity, it increases. How about even odd?
No, neither.
Nothing. You can't reflect it, right? Because there's no graph over here. So it would have to reflect on top of itself, which it doesn't here. Okay, that's it. Next one, how are we doing? Yeah, I want to get through at least the cube root. 6. Cube root. Cube root of x. So the cube root of x is somewhat like the square root of x, except you can do cube roots of negative numbers. So 0 cubed is 0. 0 cubed 0. Or, sorry, yeah. Cube root of 0 is 0. That's what I meant to say. Okay, 1. The cube root of 1 is 1. What's the next number that you would know the cube root of?
No, 8.
8. The cube root of 8 is 2. So you'd have to go all the way out to 8 before you go up 2. And so you do that. See, it's a lot like the square root function. But you can do negatives. And so it's going to be the same picture like this way, which means it's an odd function, right? It's odd. Double reflection. Domain, all real numbers. Range, all real numbers, right? Increasing all the time, right? It's always increasing. All right, I think that's a good place to stop. Don't worry about the 3.4 homework. There's about 5 more toolbox functions that we need to do. And some of them I'm pretty sure some of you have not seen before. So what's your homework for the weekend? Yeah, do the 3.3 up through 3.3 homework and start doing that review. Don't save it till what, next Wednesday night, right? Try and get going on it as soon as possible. All right, everybody, have a great rest of your day and weekend. If I don't see.
If I go to your office, would you like check my review?
If you want me to look over, I probably won't go over the whole thing, because if I were going to do that, I'd just supply an answer key.